Hi, welcome to this lesson on calculus, the factor and remainder theorems. So let's have a look at the factor theorem. Everything we've been building up so far, polynomial long division and the remainder theorem, will now culminate into what we know as the factor theorem, and this is the main theorem that we will use to utilize when we want to factorize cubic functions. So the theorem relies on the remainder theorem as well, and it is stated as follows. If a polynomial p of x is divided by this linear term cx minus d, and the remainder is given by the polynomial evaluated at d over c is 0, so that is from the remainder theorem, then cx minus d is a factor of p of x. So mathematically what this means is that we can write p of x as a factored form of cx minus d times another polynomial q of x, plus a remainder of 0. Okay, so let us examine an example of how to factorize a cubic expression of this form using the factor and remainder theorems. So let's factorize the cubic expression x cubed plus 2x squared minus x minus 2. So first we need to use the factor theorem by listing out all the possible factors of the constant term, which in here is d is minus 2. So all the factors are plus 1, minus 1, plus 2, and minus 2. So these are all the numbers that can divide into negative 2. So there's 4 of them. So this is a trial and error sort of procedure where we need to iterate through all the factors to see, do any of those factors give us a remainder of 0 when we evaluate it at the polynomial? Well, I was fortunate enough that when I took 1 and evaluated the polynomial here, so that's 1 cubed there, plus 2 times 1 squared, minus 1 minus 2, well, that gave me 0, right? So if it doesn't give you 0 at first, doesn't mean give up. It means just try the other factors until you've tried all factors. So since the factor x equals 1 gives us p of x equals 0, then x minus 1, that entire term there is a factor of the polynomial. So that's both by the factor and remainder theorems. So hence, we have that x cubed plus 2x squared minus x minus 2 can be written as this factor x minus 1 times another polynomial q of x. But we know that this polynomial needs to be a quadratic because I have a linear term here with a quadratic, and when that's expanded out, I'll get a cubic term, an x cubed term. So now we can solve for this quadratic expression in a few ways, but we will examine the two most basic ways to find this expression. The first way is by logical inspection, and the other way is by polynomial long division. So let us try both ways and see that we arrive at the same solution. At the very end, you can choose whichever method you prefer when you want to factorize cubic expressions. Both logical inspection and polynomial long division are both correct methods. So logical inspection. Well, if I write out this term x cubed plus 2x squared minus x minus 2, I know it's a factor of x minus 1 times a quadratic expression. So this is where the logical inspection comes from. Well, I know that my a term should be 1 because when I expand x by x squared, I get x cubed. And that's that term there. All right? And then I know my c term should be positive 2 because when I multiply the constants out, negative 1 times positive 2 gives me negative 2. And that's that term there. So all in all, logical inspection allows us to see the coefficient a for the x squared term and the constant term c very quickly. It is only this bx term now that we need to solve for. If we can find b, then we've factorized it. So let's expand the following terms and then compare them on the left and the right hand side. So what I'm going to do is, I'm choosing the x squared term. All right? And for the x squared term, what I'm going to do is, I'm going to see, well, what terms from this factor and that factor do I need to multiply by to only get x squared terms? Well, if I do x times bx, I'll get bx squared. And if I do negative 1 times x squared, I'll get negative x squared. And if you notice, if you take x with x squared, you'll get an x cubed, and x with 2 will just get 2x. The negative 1 with x squared gave us that negative x squared. the negative 1 with bx will give you negative bx, and the negative 1 with the 2 will give you negative 2. So you could choose to expand the full thing out and then compare both terms, but it's easier just to focus on one of them, which is I'll focus on the x squared terms. So the only terms that'll give me x squared terms on the right-hand side are these two here. So on the total on the right-hand side, we have bx squared minus x squared. And on the left-hand side, the x squared term is 2x squared. So because we're working in an equation, we can compare the two terms and equate them as follows. Bx squared minus x squared is equal to 2x squared. So I can pull out a factor of x squared on the left, and I'm left with b minus 1 equals 2x squared. Then I'll divide both sides by x squared, and I'll be left with b minus 1 equals 2. Adding 1 to both sides, I get b equals 3. Okay, so now if we put b equals 3 here, we have x minus 1 times x squared plus 3x plus 2. But this quadratic expression we can factorize further. It is x plus 1 times x plus 2. So all in all, we have three factors here, x minus 1 times x plus 1 times x plus 2. And we can double check the solution by expanding it out. X over here, well, that's a difference of 2 squares. So I'm going to get x squared minus 1 times x plus 2. And then x squared times x is x cubed. X squared plus 2 is 2x squared, negative 1 times x is negative x, and negative 1 times 2 is negative 2. And that was the original expression that we started off with, the cubic expression. All right, so that is using logical inspection. But we can also use polynomial long division. So we know that x minus 1 is one of the factors, and we want to divide that into this dividend term here. So if we do that, the quotient term on the top here, well, if I do x squared first, x squared times x minus 1 will give me x cubed minus x squared. Okay, so now if I subtract these two, x cubed minus x cubed, that's 0x cubed. 2x squared minus x squared. That's equivalent to 2x squared plus x squared. So that's where I get 3x squared. And then I bring over the remaining terms, negative x and negative 2. So now again, I repeat the process. If I multiply by 3x into this divisor term, I get 3x squared minus 3x. So if I subtract that, 3x squared minus 3x squared is 0x squared. Negative x minus negative 3x is equal to negative x plus 3x. So that's where I get the positive 2x. And then I bring over the remaining terms, negative 2. And then lastly, to get rid of this 2x, if I multiply by 2 here, I get 2x minus 2. And if I subtract those, I get a remainder of 0. So there is the quadratic expression that we worked out using logical inspection, but now we found it through polynomial long division. All right, so that is how we can use both the polynomial long division or logical inspection together with the factor and remainder theorems in order to factorize a cubic expression. So remember, the whole goal of this exercise is that when we get to cubic functions, to be able to sketch them and look at all their key characteristics and properties, we need to know things like intercepts. And having it factorized like this will be able to show us the intercepts much easier. All right, so that's how we would do this type of question. I'll see you in the next one.